All right, let's get started with this session thing idea. All right, quick introduction. My name is Rish. This is Dylan. We're gonna be your TAs for this semester. And yeah, obviously, y'all got your foundations exam this Friday. So yeah, this session will be dedicated to prepping towards that. And y'all got any questions before we start?
I'll let him, walk around, so if y'all have questions, just kind of raise your hand. But he's gonna start on the worksheet here. Y'all can work with him or try it on your own and see what he comes up with. And yeah, so I'll just be walking around. Feel free to just flag me down.
All right, that being said, question one, let's do this. Solve the following conversions. So 1200 decimeters to millimeters. All right, so this is like a what type of conversion? Like what system are we using here? Metric system, which some reason this country does not like. All right, so metric system. So we have one metric unit to another metric unit. So the prefix, this little DM, what does that mean again?
Decimeters.
Deci. So what's the power of 10 associated with it?
-1.
10 to the -1. And what is this little m right here?
Milli.
What power of 10 is that associated?
-3.
-3. All right, so I'd like to say right off the bat that you all need to memorize your metric prefixes, something you need to commit down to memory. So just to make sure that we're on the same page here, let's go through all of them. There's one with a capital T, what's that called? Tera. G is capital G right here. Giga, yeah. We'll go through the powers of 10 later, but. All right, in semesters past, I've gotten flamed for having terrible handwriting. So if at any point my handwriting sucks, let me know. All right, there's one with the capital M, what's it called? Mega. All right. One with a K. Kilo. Then this one right here is just, we'll call it B for the base unit. This can be anything, meters, liters, etc. Anything that doesn't have a prefix. Base, let's call it base. All right, we just went over this one, lowercase d. Deci. Then we have lowercase c. Centi. Lowercase m. Milli. There's this weird Greek symbol. Micro. Now we're getting really small. Lowercase n. Nano. And then lastly, lowercase p. Pico. All right, let's go through the powers of 12. Or powers of 10. All right, so Tara, what power is it?
15.
12. 1 trillion, in other words. 10 to the power of 12. Giga, what power is that? 10 to the 9. 1 billion. Mega. 10 to the power 6 or a million. Kilo? Yep. Kilo, the kilogram, 1,000 grams. Base, we'll just call it 10 to the power of 0, which is what? Yep. Deci? Yep, 10 to the -1. Centi? 10 to the -2. -3. -6. Nano? 10 to the -9. 10 to the -12. All right, so y'all got that pretty much down. So here's how we like to do metrics and metric conversions. All right. So first and foremost, what we're gonna do is we're gonna write out our unit here, 1200 decimeters. I use this little train track method or whatever it's called, but I don't know, my train tracks is like curves, whatever. This is like one of those like circular train tracks. Anyway, so decimeters, right? First thing we're gonna do is convert from decimeters to meters. Because this is like one of those like trades. You gotta have a middleman in between. So we go from whatever unit we're at to our base unit, and then back to the unit we want to go. That's the usual format for any of these. So 1200 decimeters, right? How many decimeters are in a meter?
10 to the first.
Yeah, or just 10, right? So 10 decimeters are in 1 meter. You could also do this in scientific notation if you wanted to, but you're gonna have to like switch some stuff around. Like one, for instance, you could say like one, what's it called? 1 decimeter is 0.1 meters. That's also acceptable, but yeah. All right. Now, how many millimeters are in a meter? Yep, so 1,000 meters are in 1 millimeter. And here's our end goal of what we want to have, right? So you'll notice here, decimeters cancel out, as do meters. So all we're left with in our numerator is millimeters. So if we solve this out, somebody be brave and take out their calculator, what do we get? Right, it's me, 0.12.
Should be
No,
a
you're
1,000
right.
millimeters.
You're right. I think it's supposed to be 1,000 millimeters is in 1 meter instead of,
Oh, yeah, my bad. Or writing on my part. 1,000 millimeters in 1 meter. 1,000 millimeters. There we go. Yeah, that's right. All right, so we cancel that out. All right, so it'll be slightly different from 0.12. What is the answer instead? Louder, sorry. 1.2 times 10 to the 5th. And this is in millimeters. All right, a general rule of thumb, right? I should have pointed this out beforehand, but if you go to a prefix that's smaller, so 10 to the minus 3, right, is smaller than 10 to the minus 1, your answer should be bigger than the thing you're starting with. So in this case, right, 1,200 decimeters, deci is a bigger prefix than milli, so our answer should be bigger. So 1.2 times 10 to the 5, that's bigger than 1,200. That's what I mean. All right. Sig figs. Sig fig wise, how many sig figs should we have? Just 2. And do we have that in our answer?
yes.
Yes, we do. All right, cool.
I got it.
Right. You got next. Shout out 2K.
All right, let's draw out a game plan. So similar, Rich kind of said, we want to go to whatever unit we're given, we start with, and we go to our base unit, and then we go to the desired unit. So we're starting with nanoliters. And then what do we want to go to from here? Liters, and then we go to, what's this one? Picoliters. All right, so 14 nanoliters. I'll do it a little different than Rich. This is how I've done it since sophomore year high school. So how many nanoliters are in a liter or vice versa? What's the prefix? Or it's power to -9. So we know that 1 liter equals 1 times 10 to the 9th nanoliters, or we can say that there's 1 times 10 to the -9th liters in 1 nanoliter. They're both the same, so whether you use the top one or the bottom one, you're gonna get the same answer when you put it into the calculator. So I'll just use the top one. And we say 1 liter is equivalent to 1 times 10 to the 9th nanoliters. So right now we've canceled out our nanoliters unit, so we're back in the base unit. So we went from nanoliters and now we're here in liters, right? So now we need to convert from liters to picometers or picoliters. So how many picoliters are in 1 liter? Right, so you can write it as there is in 1 liter, there's 1 times 10 to the 12th picoliters, or you could have said that there is 1 times 10 to the -12 liters in 1 picoliter. if you substitute that section. So either one will get you the right answer again. So who has a calculator here and who can put this? Or, I mean, you really don't need a calculator, but we're gonna be given one on the test, so might as well use it, right? So what do you get? Times 10 to the fourth? Okay, 1.4 times 10 to the fourth. And these units are now picoliters. All right, so that's metric to metric. How do y'all feel about metric to metric conversions? Good? All right, so let's go to metric to English. How do y'all feel about those? Are those a little bit more confusing? All right, we'll go to metric to English or vice versa. So let's do. We're going from metric to English, grams to pounds. And the question is, if we're dealing with mass here, right? We're dealing with mass. We're not dealing with volume, and we're not dealing with anything. What is it? Length, volume, and there's one other one.
On probably.
Oh, something like that. Yeah. So the I usually memorize one conversion factor from metric to English for each of the three things. So for weight or for mass, like we're doing, I'm going to memorize that there's 1 kilogram is equal to 2.205 pounds. So that's what's going to get us from the metric to the English system of units. So if you're dealing with volume, you're going to want to use something like this. Which one do y'all memorize?
Centimeters cubed to liters.
Yeah, that's a good one. So that's one. I always memorized 1 gallon equals 3.785 liters. But it's also good to know that 1 milliliter is equal to 1 centimeter cubed. That's also a very important one as well. So those are the volume ones. So we have mass here. Volume. And then you need one for length. So the one that you should memorize for length, which one do y'all think it is?
1 inch is equal to 2.54 centimeters.
Yeah, 1 inch equals 2.54 centimeters. And it's important to note about, it's important to note about this one is that this is the only metric to English conversion factor that is an exact number. So what does that mean for when we take into account sig figs? Are we going to take into account these numbers when we're looking for our sig figs? No, because it's an exact numbers. How many sig figs does an exact number have? Infinite, right? So you don't want to be punching in on your iClicker an infinite number of zeros. So this is, again, that's only for this one here. Exact, so we don't worry about sig figs. All right, so let's start with our given. And let's just work our way down to pounds. So 205,924 grams. That's a G, by the way. Okay, let me erase that. It's getting ugly. What should we go do next? Kilograms, right? Because if we're dealing with mass and the one conversion that we memorized, or that I memorized at least, because I'm not going to memorize all hundreds of them, is this one, then we need to get to kilograms so that way we can go to pounds. So we know how many grams are in a pound or in a kilogram. Yeah, so there's 1,000 grams or 10 to the third in 1 kilogram. And we know from what we memorized, because this is not going to be given to us on the test, right? We know that 1 kilogram equates to 2.205 pounds. So when we put that into our handy dandy calculator. What do we get? 454, okay. We might need another sig figure or two. 0.026 or 0.062. All right, so this has 6 significant figures right now. How many sig figs should we have? And where are you getting 4 from?
Kilograms.
Exactly, because this is not an exact conversion factor, you have to take into account this conversion, and we look at the number of sig figs in this number here. So you don't look at this one, because then it would just be 1 sig fig for everything, you look at this one. So it's gonna be 4 sig figs in this final answer, so 4 sig figs for this would be what? 454.1. Do we agree on that? Yeah, we're gonna round that 0 to 1. Okay, that's a metric, or yeah, metric to English conversion. How do you all feel about that? Want another one, or do you want to go to naming? Oh, we got, yeah, go ahead.
If you use a different like conversion, for example, if you did like grams to pounds, like 454 grams to 1 pound, and then that has 3 sig figs, then you would go off of that one.
Whatever you used in that, yeah. Mhm.
So there'd be multiple answers technically.
Yeah, there'll be a range of answers that are acceptable on the iClicker.
Unless they specify otherwise that it's specifically exact.
Yeah. You have a question?
Do you need to know like kilometers to miles?
You don't have to, because as long as you know that there's, if you know how to get from kilometers to centimeters and then inches to miles, which is, there's 12 inches in a foot and there's 5,280 feet in a mile, then you don't have to memorize every single metric to English conversion. So if you memorize your English to English conversion, so like inches in a foot, foot in mile, then you can get anything like kilometers to miles. Yeah.
So if we had like this question on the test, but it told us to use 1 kilogram to 2.205 pounds, then we would have to use that one, and
Yeah,
I
you
have
would
to
have
pass
to.
that 4 sig figs.
Yeah, exactly. So that's a good question. If they give you this conversion factor on the test and say, use this one, and you go ahead and use the other one that she was talking about with the grams to pounds, and you get different sig figs, then that's gonna be on you. Because the test says do one thing and you did another, okay? I mean, you might have a similar answer, but different sig figs. So just read carefully. You wanna do naming, or do you wanna do another one of these? Naming? Naming, all right, let's do naming.
For nomenclature regarded by many as the most boring part of chemistry.
I'll let Rich go ahead and start on a couple here, and then I'll walk around. Again, if you all have any questions, this is the time to ask. We're all once in your position too. So just ask your question. Okay, I got some questions over here.
All right, as I said, naming, boring, but you're gonna have to do it anyway. So for each of the following compounds, give the name or formula. All right, so
Only if it's exact.
Cu2S, what we thinking?
You wouldn't use sig figs from
Right,
that.
we got multiple answers of the same thing.
Anything
The
else.
name
like
is
what we
indeed
just did with
copper
kilogram to pounds.
2
It's not exact, so you have to take into account
sulfide.
those sig figs.
What's the 2 though? Why'd you include that there?
There's only one exact one. This is yeah, so that's, it's a little easy to remember that one. Yes. Good question. Is that your question?
All right, so here's a good thing, we're gonna do the good old method, so. Sulfur has what charge? -2. So 2 minus.
Where do you
And
get that
copper
from, Rich?
has what charge? All right, so for those of you who do not know where that 2 minus charge comes from, you can look at your periodic table right here, and yeah, the column it's in tells you the particular charge. So the alkali metals here on the far left, they have a charge of +1. You go over a group, it's +2. Transition metals, we'll talk about those in a bit. Then +3, +4, -3, -2, -1. So pertaining to the question, sulfur is in that column, which has -2, so sulfur has a -2 charge. And then it's interesting, right? There's no subscript here behind this sulfur. So what that tells me is that copper actually has a +1 charge. So the actual answer is not copper 2 sulfide, it's copper 1 sulfide. The reason, always pay attention to your charges, basically look at the subscript behind each element. So if it was copper 2 sulfide, here's what it looked like instead, it would be CuS. Since each of these would have a subscript of 2, and then you always reduce everything, so 2 and 2 becomes 1 and 1, so it becomes CuS at that point.
Yeah, make sure y'all just, I guess some students can forget what the Roman numeral means. That means the charge of the transition metal, not how many transition metal atoms are in that complex.
Yeah, and then another thing, why do we use that 1 or 2 in the first place? Why is that even there?
Those transition metals have different charges or can have like different charges.
Yeah, transition metals can have multiple charges generally. There are exceptions to this. So what are the exceptions? Do y'all know?
So
Aluminum?
Aluminum's not really an exception. It's in that it's in that +3 column, so it would still have a +3 charge. Iron isn't. There's 4 elements of the
silver's one of them.
silver is one of them. Silver has a charge of +1 always. Zinc is one of them, has a charge of +2 always. Cadmium is one of them, also has a charge of +2, and I heard somebody else say scandium. Scandium always has a charge of +3. These are the 4 that the charges never change, so you don't have to include any Roman numerals for them. In fact, if you do include Roman numerals, we're required to take like 10 points off for each Roman numeral you put, so yeah.
It's important to know that in this class, we like to test you on the exceptions. So if it's a naming multiple choice question, and you're most likely gonna see something with scandium, zinc, cadmium, or silver. And it'll give you multiple choice options, right? And some of them will have Roman numeral, some with the correct charge, some of them won't have a Roman numeral. And it's your job to remember, okay, does not require Roman numeral because it only has 1 charge. Therefore, there's no need to have a Roman numeral for it. Does that make sense? So again, pay attention to all the exceptions in this class. They're very important.
All right, that being said, there is another way to name this compound. Y'all tell me what it is. Latin naming scheme problem. Cuprous sulfide, that's it. Cuprous sulfide, I probably spelled that wrong, but cuprous sulfide. So the way you arrived at that, right, is copper can have 2 charges. It can either be +2 or +1. Those are your only 2 options. So you can have a copper 2+ or copper 1+. So for the higher of the 2 charges, you'd use the suffix "ic" along with the Latin name. So this would be like cupric, whatever the non-metal is. And then Cu+, right? You use the suffix "us," O-U-S. So this is cuprous, and plus whatever the non-metal is. So yeah, you can name it copper 1 sulfide or cuprous sulfide. Either name is acceptable. All right. Any questions? All right. Let's try out this next one. Ferric selenide. So selenide corresponds to which non-metal? Selenium. What charge does selenium have? Use a periodic table, that's allowed.
Say it louder. Say it louder.
No.
-2. I heard someone. So selenium has a charge of 2-. So we'll keep that aside for now. All right. Ferric, what element does ferric correspond to? Iron. So, yeah, iron. And what charge does iron have in this instance?
Two.
Interesting.
So iron can be one of two charges. It can either be +2 or +3. So which charge is iron if it's ferric? +3. Remember, the higher of the charges, you always give the ic suffix. So since 3 is greater than 2, ferric would be +3 instead of +2. So +3. All right. Now, people call it different things. He calls it the crisscross method. I call it the loop-de-loop method. Point being, you switch the two charges and make them your subscripts. So the +3 goes down here, the 2 goes over here, and then your final result is Fe2 Se.
Comes from the Greek name for ferrous, or no, not ferrous.
Any questions on that?
So we're doing this.
What if it was ferrous selenide? How would you name that?
And name. And that tells us the higher charge.
So Fe, or that's close, right? But we always reduce down to the lowest term. So 2 and 2 reduces to 1 and 1. So it'd be Fe.
Has two charges and what those charges are.
Yeah.
So iron is +2 or +3. That's something you have to memorize. Now, if you know that, then you can say, okay, it's ferric.
Either name is
iron.
fine. So, yeah. In here, for this one, they want you to use the Latin naming convention.
Okay.
So the, like ferrum is the Latin name for iron, so that's why they use that. Either one's acceptable. Yeah.
Just so it memorized like the Latin names for all the.
Same thing with copper.
Not all of them, just ones that do exist. So iron, ferrum, gold is aurum, silver, argentum. And honestly, you don't even have to go that deep into it. They'll give you like half of these. Just remember that anything with a Latin name has a symbol that doesn't correspond to like the letter in the name. Like for example, iron, Fe, there's no F in iron or E in iron for that matter. So, yeah. Same case with like something like silver. So there's no A in silver, there's no G in silver either. So that's how you know it has a Latin symbol. The only exception to this is copper. So copper, you'd still use cuprous and cupric, even though, you know, it doesn't have Latin symbol.
Yeah, and some other popular ones that you might see on an exam are tin, SN, which its name would be stanic or stannus, and lead, which is plumbic or plumbus. That's the Latin terms for these.
So I'll just write these out real quick because I think I'm overwhelming all this information. So iron, ferrum, gold, aurum, AURRUM, silver, argentum, ARGENTUM, argentum.
But that's only has one charge, so you really don't need to know that one.
Yeah, I'll just put it on there for extra fun facts. Tin, stannus, stanic, whatever. Not those are the prefixes you use. The Latin name's probably some variation of that. I just don't know. It's not coming to my head right now. Tin, then lead. So lead, PB, think plumber, so plumbus and plumbic. So the Latin name actually is plumbum. That's what it is.
So all you need to bring to the table is the two charges that are associated with each one. And then the ick and the us will tell you which one you're dealing with, okay? So that's something you gotta know.
So, we'll be nice and give you those two. Iron can either be +2 or +3. Gold, don't worry about that one. Silver, as we said, +1. Tin can either be +2 or +4. Same with lead, +2 or +4. Copper, can either be +2, +1. I think that's.
Yeah, this is pretty much all you're gonna see on the, like, possible things you'll see on the exam. You were raising your hand.
Yeah, it's still a little. I don't think y'all signed up to take Latin, but yeah. All right. Are y'all good with part B? You realize why that's the answer. All right, let's move on to part C, ammonium bromide. What's that? NH4, that's the first part. What's bromine? Br. So why aren't there any subscripts or anything on this stuff? Yeah, ammonium has a charge of +1, Br has a charge of -1. So study up on your polyatomic ions that might show up. So, yeah. Speaking of polyatomic ions, we got this next one. MoC2H3O2 4. All right. Some long thing, right? Let's break it down. So this is always what I like. C2H3O2. What does that one correspond to? Acetate. That's what the polyatomic ion is. So it's something acetate. Then MO, what element is that? Close enough. So it's molybdenum. Just remember to spell it right. That's all you need. All right, so here, what charge is on our molybdenum element? 4. Is that a positive or a negative?
People on the test can have the names on it, or just.
It'll just have the symbols, not the names. You kind of know, yeah, you didn't sign up for spelling either, but yeah, you're gonna have to spell. All right. So molybdenum, started somewhere, has a charge of +4. If you're ever confused, look at what area of the periodic table it's in. Molybdenum, right, is one of those transition metals, and a metal can't really have a negative charge. So yeah, it will be positive. So molybdenum is +4. That being said, molybdenum is a transition metal, right? And it's not one of those exceptions we listed above. So what do we have to include in our name?
The memo.
Yeah, the Roman numeral. So it'll be molybdenum. I mean, I can't even spell. But something like this, molybdenum. Then what's the Roman numeral we included? How do you write that again in Roman? IV. So molybdenum 4 acetate. Acetate. That is the name for that. All right. How y'all feeling on naming? Want to do some more?
Yeah.
All right. Let's skip this one. Skip that one too. All right, sodium cyanide. What's that gonna look like? NaCN. The sodium, sodium chart, the symbol is Na. And then Cn minus is the polyatomic ion cyanide. So sodium cyanide. All right. This one be kind of on the more difficult side. Let's go ahead and pretend here that this element acts as a transition metal and has a certain charge. So with that being said, we have here PuOH3. So OH corresponds to what polyatomic ion? Hydroxide. So that'll be part of our name. Hydroxide. All right. And what is Pu? What symbol is that? But yeah, you notice it's not a transition metal, but let's act like it is. So plutonium. And then what do we put in in our name, since we're thinking it's a transition metal with multiple charges? Or not this one specifically because it has a Latin name, or it doesn't have a Latin name. But we need something else, certain set of numbers. Roman numeral. So plutonium 3 hydroxide. Hydroxide. All right. Any questions on that? Right, I'm gonna go a little off script here, see if y'all can think of this. Let's do AL 2O2. How would you name this? Aluminum's part of it, right? What is this polyatomic ion called? It's close to hydroxide, but no. Peroxide, aluminum peroxide. In case y'all have never seen this polyatomic ion before, peroxide is O2 2-. As the symbol for that. All right. Do this one. I. Silver arsenide. Would any brave volunteer like to come up to the hot standing desk and write whatever formula they think this is? Anyone, any brave volunteers? Go for it. Silver arsenide. Your periodic table expressed on the home screen.
Okay, so we know that silver is Ag. And that's a plus. Arsenide. What do I press for the periodic?
Home screen. Or just press the home button.
Arsenic. Arsenic has a charge of -3. I get back to little,
Press that.
alright. So this one's 3. So I'm just gonna put that up to the side here. Minus,
So yes, actually, this is chemical symbol.
what's up?
Chemical symbol's AS, not AR.
Was AS?
Yeah.
Alright, so silver. Silver's still a transition metal though, right?
It is, but what's special about it?
As a plus. But what I would do here, and it's probably wrong, is I would say Ag. Part of that looks to write all this. Yes. That's what I would write.
All right. Can somebody tell me what he did wrong?
Silver is one of the exceptions, so we know that silver is +1.
So it would just
What does it
be,
need?
what, Ag3As?
AG3 AS, yeah.
Alright, so what we would do is see this three right here, you would actually write Ag3As.
There we go.
Yeah.
Four points.
It's also important to just kind of think that the Roman numerals should only go into the names, not the formulas, all right? So if you got a Roman numeral somehow getting into your formula, you might want to backtrack a little bit, okay?
Formulas are straight up like regular numbers, and then the names you use Roman numerals. Right.
I'm gonna have to leave soon. I think I might have told some of y'all that we're having a general meeting for the American Chemical Society at 5 o'clock today. And it's in the BSB in the Loeffler room. If we're gonna have some free food, so if you wanna go after this, feel free. But yeah, I'll see y'all there. This isn't gonna happen every week, it's just today's very special.
Joining the chemistry society, would that be a good way to also get help in chemistry?
Oh, yeah, yeah. Definitely. Especially because you meet a lot of like-minded people taking the same classes, you know? But yeah, so see y'all there. Have fun. I'll see you on Wednesday. Bye.
Right, awkward exits aside. Let's move on to J. Zinc bicarbonate. So bicarbonate, what polyatomic ion is that again? Another way to look at it is hydrogen carbonate. It's also another way to say it.
Oh, I think
Chromate.
Carbonated CO3, right?
Yeah.
So it'd be CO3 and then parentheses on the bottom, or it'd be.
Well, so this is bicarbonate, so let me teach you a derivation. Carbonate is CO3 2 minus, somebody said, so CO3 2 minus. But here, since it's a bicarbonate, what actually happens is you add a hydrogen, and if you add a hydrogen, you decrease the charge. So instead of HCO, or instead of CO3 2 minus, it's HCO3 minus. All right. And then what's zinc again?
Yeah.
What charge is that? +2. So what would our formula be at the end of the day? DNHCO3. So we put the parentheses like this, and then 2. All right. This is naming, probably the most boring part of chemistry, but we're gonna do a little more of these, just so y'all have a little more practice. Let's move on to letter N right here. N for Nancy.
So if it has bi at the beginning, has H
Yeah.
in all five.
Mhm.
And then also for that one example, you said plutonium hydroxide. Do you actually like treat it as a transition?
No, that was just for the sake of the example.
Like if you write it, there's no Roman.
No, y'all aren't gonna be really tested on that area of, yeah, that's a whole complicated mess. All right. So XEF6, how would you name this one? We have a xenon, right? Yeah. Xenon hexafluoride, that is correct. Xenon, because xenon, and then hexafluoride. So hexafluoride. All right, let's do some breaking down of how she arrived at that answer. So let's do our prefixes. I'm gonna write out a list of numbers here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, first and foremost, what type of compound is this? Ionic or covalent? Covalent. So covalent compounds, right? You had to use your prefixes. All the ones we dealt with before were ionic compounds. So now we're gonna have to change it up. We're talking about covalent compounds here. All right. So 1, what's the prefix for that? Mono. Think of the disease. I don't know to remember it. 2. Yeah, di. This is pretty easy to remember. 3. Sure. This is even easier. Think tricycle. 4. Tetra. This is a bit difficult, but if you remember your biology, a tetrad has like 4 units on it. So that's one way to remember it. 5. Penta. So can't give you an easy way to remember this one, but just do. And then from here it gets easy. 6. Hexa, like hexagon. Or 5, you could, yeah. 5, you could just remember pentagon. I just realized that now, but hexagon. 7. Hepta. Yeah, because I don't know, chemists are weird like that. So it's a heptagon, not a septagon. So hepta. All right, 8. Octa, octopus, octuplets. Think anything. Octagon. All right, 9. Think Italian for grandmother. Yep, no. All right, 10. Deca. Decathlon has 10 events. All right. This is what I like to, the reason why I said that in the first place is because this is how I remember stuff. Like I just associate it to stuff I've seen in my life. Like mono, I know the disease. Di, like a dye, like something that's dye substituted as 2 things. Yeah, that's how I remember stuff. So it might work for you, it might not, I don't know. All right. That being said, let's try a P. so arsenic pentafluoride. We have any other brave volunteers come up and write what the name could be? Arsenic pentafluoride. That is correct. ASF5, arsenic pentafluoride. So, yeah, ASF5. So one important thing to note is that for covalent compounds, you only use the prefixes for the second element. So say for example, like arsenic, right? You'd only use it for you wouldn't say like mono arsenic, even though there's only one arsenic, you'd use it. If there's only one of the element, you only use it for the second. Say for example, there were two arsenics though, you'd still say diarsenic. That makes sense? Basically what I'm trying to say is if there's one, if the first element only has one of them, then don't use a prefix for the first one. But if they have multiple, then just use your, go crazy with your prefixes. All right. What sort of practice do y'all want to do? Ionic, covalent? What's more difficult? Roman numeral stuff? Yeah. Or, you can go first. Acids, all right. Y'all want to go straight to acids. Let's see if we have any acids so far. All right, we do not, but I will mix them up. All right, so HNO3, what is this one called? Oh, yes, maybe. Yeah. Nitric acid, that is correct. All right. So here's what y'all need to know. Basically, to get good at naming acids, you got to know your polyatomic ions. That's pretty much all there is to it. So NO3 minus, right? What polyatomic ion is that? Nitrate. So if it's nitrate, right? Anything with an 8, use the ic suffix. Anything with an ite, you're going to use the us suffix. If you know those two rules, then you're pretty much golden for all acid naming. And then to indicate the hydrogen, all you got to do is just put acid at the end. That's it. So step 1, know your polyatomic ions. Step 2, what's it called? Yeah, step 1, know your polyatomic ions. Step 2, write out the suffix, figure out which suffix it is. And step 3, just slap an acid onto the end. All right, so we have nitric acid. What about this one? Yeah.
Sulfuric acid.
Sulfuric acid. So again, what polyatomic ion is this SO4? That is sulfate. So 8, use the ic suffix. So sulfuric acid. All right. What about this one? Let's make it a bit more challenging. Perchloric acid. So what polyatomic ion does this come from? Perchlorate. So another rule with your polyatomic ions, right, is ClO3, right, is chlorate. So if there's one more oxygen, it would be perchlorate. If there was fewer oxygen or one fewer, it'd be chlorite. And if it was 2 fewer, it'd be hypochlorite. So it always goes in the order of hypo is lowest. Then I'll just say ite, then 8, and then per. So say I had something like nitrate, right? This is NO3. nitrite, NO2, hyponitrite, NO, and then pernitrate, NO. So just add the number of oxygens. The only thing that changes is the number of oxygens. The charge will always stay the same. All right, perchloric acid, because again, perchlorate and then acid because there's a hydrogen. All right, what about this one? Hydrobromic acid. So here's sort of a special thing, right? Whenever there is no oxygen in your thing, you have to use hydro. So it's just H and a Br, right? There's no oxygen involved. So because of that, you have to say hydro. So hydro indicates the hydrogen and bromic indicates bromine, hydrobromic acid. Right? And this goes for like any of those, like HCl, H whatever. So what about this one? This is kind of a tough one. So I heard it somewhere, hydroselenic acid. Because remember, is there an oxygen in this H2SE? There is not, so you gotta use the hydro thing. So hydro, and then selenic refers to selenium, so acid, hydroselenic acid.
So
Yeah.
the 2 on the hydrogen doesn't do anything for the name.
You don't have to put like di anything, so it's just hydroselenic acid. Just indicating the hydro part is enough. Right? Somebody give me an acid, any acid.
CL.
HCl, all right, now name it.
Hydrochloric acid.
Hydrochloric acid. That is correct. All right, let me give you challenging problem. This is sort of a exam type question. Let's say this. A new element, the new element named carium, CARRIUM, and symbol is CI, has chemical properties similar to sulfur. Say that, sulfur. What is the name or third question? What is the formula for hydroauric acid? H2CI. Is anybody confused on how to answer that question?
Why is it H2? Is it because it's similar to sulfur?
Yeah, that's literally the reason, right? Because this is just some new element that really what they're doing by asking this question is testing you whether you know how to name stuff. So since I said it has similar properties to sulfur, that's why you could deduce that it had a -2 charge. In which case, that's why it said H2CI. Anything else y'all are feeling fuzzy about?
Can we do redox? Is it gonna be oxidation number?
Redox is okay, I don't think we can do a couple,
Okay.
Yeah, because redox is a whole thing in and of itself, so we can do a lot more on Wednesday, but yeah, we should just have some like straight up oxidation of questions.
Yeah, oxidation.
Okay, let's do this one. All right, assign all the oxidation numbers in, for these elements. So copper is solid, right? What's the oxidation? 0. Why is it 0?
But it doesn't.
Yeah, it's in its elemental form. So because it's in its elemental form, the whatchamacallit, the oxidation number is 0 for any elemental form thing. Similarly, sulfur, what is the oxidation number for that? Let's make this S8. What is it now? So something you gotta know, S8 is the elemental form of sulfur. That's how it is indicated. Like, you know how hydrogen is H2, like we call it diatomic? Sulfur is what we call octatomic. So it's S8. So 0 again. All right. So now, what is the oxidation number here for sulfur in the products, on the products? Number 2, positive or negative? -2. Right, sulfur -2. So what does that make copper? +1. Because remember your overall thing has to add up to 0. All right, a little bit of a bonus question for y'all. Which element is oxidized and which one's reduced?
Sulfur is reduced.
Correct. So copper, right? Remember when it's getting to a more positive oxidation number? That means it's getting oxidized. And a more negative oxidation number means it's getting reduced. So another follow-up question. Which one is my oxidizing agent?
Sulfur.
The sulfur. Wait, oxidizing agent, yeah. It is sulfur because remember the oxidizing agent gets reduced. And what is my reducing agent? Copper. Remember the agents do the opposite of what they do. So oxidizing agent gets reduced, reducing agent is oxidized. All right, it's almost that time. It's almost quitting time. So, all right,
So you said copper is reduced?
copper is oxidized. It's a reducing agent. All right, thank you all for a great session. Our next one will be on Tuesday, 12 to 1, in the main building, room 1.126. I'll send out an email with more details about that, probably tomorrow or Wednesday.
So it's tomorrow, 12 to 1,
Wednesday.
Wednesday,
Yeah. Sessions are gonna be Monday, Wednesday, Friday.
12 to 1?
Yeah, Wednesday will be 12 to 1.
Will it be on Zoom as well? Or is it
Yes.
only in person?
We'll be on Zoom, and if you can't make that either, I'll post a recording as well. Oh, so
Thank you.
that goes for like all, like every session this semester.
a review sheet. Right.
Yeah,